Hi everyone, today we're going to cover section 1.2, science context, that kind of just goes over what type of different characteristics and mentalities scientists have to have in order to be in the field, and some background about what scientific theories are. Um, Certain characteristics like having curiosity, skepticism, open-mindedness, and creativity are all important characteristics that scientists need to have in order to create the new innovative ideas that really kind of drive science. So let's explore those. Curiosity, I think everyone sees even tiny kids can make really great scientists because they're so curious about the world around themselves. So if you're really good at asking questions and thinking about questions that maybe no one else has thought of, that is a good characteristic of a scientist. Being skeptical is also a good characteristic to have. There's lots of information that's out there that's thrown out that not all of it's valid, especially with the internet nowadays. So you have to be really wary about what's going on, what type of information you are reading, if the any sort of scientific finding is coming from a reputable source. So um, good scientists are skeptics, which means that they question existing ideas and hypotheses and they refuse to accept explanations without evidence. So you always need to see what evidence, how was the experiment done? Was it done correctly? Was evidence recorded in a way where it wasn't recorded, where any sort of outlier data was erased so that the data would conform to the hypothesis that was made. So it's very good to be kind of look into how an experiment was run or how the results were presented. So, for example, my sister-in-law over this summer posted this on Facebook, and she was like, "Is this real?" So here's this site, realpharmacy.com. I don't know, doesn't look very reputable. Again, you kind of want to look for something that ends in .gov, .edu, um, for kind of true, full-fledged scientific information data. So here, scientists blow the lid on cancer and sunscreen. So this little excerpt right here says a article is featured in this independent UK newspaper or magazine by a major study conducted by researchers in this institute in Sweden that found that many women who avoid sunbathing during the summer are twice as likely to die as those who sunbathe every day. So that kind of goes against all of our ideas here that, oh, the sun, the UV um, radiation can cause cancer. So I was reading this and I just kind of went on a skeptical rant on her little post here. Here's what I wrote. My whole little kind of skeptical rebuttal here. Um, I was looking for that original article that was in that Sweden, and I could not find it in any sort of scientific database that I have my hands on. Um, I quoted things from like the National Institute of Health, which is a government site, the Center of Disease Control, that obviously there's much more data that and evidence that says the opposite, where UVA, UVB exposure does increase the incidence of cancer. So you can read all that if you want. I'm not going to read it all right now. But many other people on her friends list agreed. Um, People I know too. But it was just funny, and obviously she thought it was kind of bogus too, but she was glad to get some other information out there as well. Being open-minded, so kind of the opposite of being skeptical. You not only, I mean, you do want to be skeptical, but you also kind of want to keep an open mind, because you don't want to close yourself off on any sort of idea that maybe could lead to, a new vaccine, a cure for different diseases. So you want to, if you want to keep an open mind for any sort of possibilities. Being willing to accept different ideas that might not agree with your original hypothesis. So not being too stubborn in that way. Hand in hand with open-mindedness, being creative. Obviously, if you're creative, you're going to kind of think of new innovative ways to maybe test something that maybe no one else has thought, that again could come up with a new vaccine, for example. Obviously, technology has a huge role in science. As technology advances, we can, find obviously new things in science, especially when we get smaller and smaller. We can see on the nanoscale now, based on having electron scale microscopes. Um, so obviously, technological advances have also big impacts on daily life. Um, so we use a lot of genetic technology now, um, where you can see obviously if people are related to one another. You can look and see for different genetics, for example, for making genetically modified organisms, plants, um, genes that would kind of inhibit certain maybe bugs that plague certain plates from eating them, introduce these genes to prevent those bugs from eating the plant, or like bringing in drought resistant genes. So it depends on the person or the institute you talk to, being pro or against genetically modified organisms. That's a whole big debate now that's still kind of up in the air about if it's good or bad. When you are um, presenting scientific information, it is going to be peer reviewed. So if you are, later down the road, if you're maybe going for your PhD in science, part of that is you have to get published. And so when you get published, you get peer reviewed. So the whole point of peer review here is having a system of like checks and balances. So making sure that scientific information that's presented is thoroughly looked through. So there different um, different people that are very well established in their field are going to review material related to that field. So they're going to look for any sort of oversights, unfair influences, any fraud, mistakes, any sort of bias. So if there maybe some company was kind of sponsoring an experiment, obviously there's going to be a conflict of interest there. So peer review kind of makes sure that um, scientific information that is published is valid, that there's not any sort of um, wrong information being presented and um, you know skewing the population, or information that's put out to the kind of overall um, everyday people, that everyone's going to be getting the right information out there. Sharing knowledge and new ideas. So once research has been published, it may spark new questions. So um, there might be labs that are currently working on some sort of problem that they've been working on for several years, and then maybe some new research comes out and they re-examine their hypothesis. They're maybe based on this new information that's released, they're going to change their hypothesis, how they're going to tackle a problem to solve it. So you wouldn't ever just say, oh, well, that new information, I'm not going to listen to it. I'm just going to keep on doing what I'm doing. You always are trying to look for new information to kind of help maybe another problem get solved. So that's what's really important about having scientific journals, peer review, is that some information that's currently found in the long run might help, 10 different problems get solved. So that's always an important part of science. Scientific theories. So the word theory, okay. Um, in everyday language, theory kind of has an kind of a wishy-washy sort of definition where it's like, oh, it's just a theory, meaning it's just a thought, or kind of on a whim, like hunch. Theory in science is um, much more than that. So it's it's an idea, it's a well-tested explanation that's been tested repeatedly, that kind of unifies a broad range of observations and hypotheses that enables scientists to make accurate predictions about new situations. So a theory is a well-tested over and over again. It's very established. So it's not just a thought. It's something that's been kind of seen over and over again to be true. Um, again, a well-tested explanation. So a theory explains why some sort of phenomenon happens. It's an explanation. Um, so a theory, though, also in science is changing. So a theory might not always be the same year to year. It might be tweaked a little bit, might even be replaced. But as technology advances, as new information is received, as new evidence is uncovered, a theory may be revised or replaced by a more useful explanation. So we're going to be talking about the theory of evolution um, later in second semester, but that is the theory of evolution is supported by all sorts of well-tested explanations like genetic information, fossil record, plate tectonics. So there's lots of information that supports the theory of evolution that explains why things change over time, which is like a law. Things change over time. Avoiding bias, so again, just kind of hand in hand with being that skeptical scientist, good characteristic. Um, you want to again make sure, especially with the internet, you want to make sure where you're getting your information. It's again other information that's provided besides something like a .edu or a .gov. Um, you need to kind of look out for to see, well, what site is someone else sponsoring that site. So for example, obviously if some sort of information was released talking about, for like, oh, oil spill in the Gulf really did not affect um, the ocean life there so much, you want to look to see, well, who did that experiment? Was it someone being sponsored by BP, um, the BP oil company? Because obviously there's some bias there. So again, you want to look to kind of double check what type of resources you're looking up. One really good resource, just for your own knowledge, is ScienceDaily.com. I know it's a .com, but they are pretty much a site that takes in um, published information from universities and journals. So it's a really good site that provides a bunch of peer-reviewed material that's very reputable. So ScienceDaily.com every day has a plethora of information that they present. Understanding and using science. So what we're going to be doing in this class, we don't want you to just memorize facts. Nowadays with Google, it's kind of an antiquated um, kind of system to just memorize everything. Now there's going to be some stuff that we're going to want you to know pretty well, that just some basic information to have some good science um, factual information. But we want you to understand how scientists develop ideas, how to understand how scientists do science. So we're going to be practicing that a lot with looking at experiments, looking at how to manipulate independent variables, how to have a controlled experiment. So we want you guys to understand how to do science, not just information like facts. Um, Again, so really important for, just general societies to have a basic understanding of science, because a lot of we can affect a lot of things based on our power to vote. So there's you want to look out and see what type of what are politicians presenting, have some not having some good knowledge of science. Some of these politicians sound a little kooky. So you have the power to say, hey, I don't want you to be in this public office because you don't seem to have a good understanding of science, or you don't respect it so much. So we want to give you guys some power of knowledge. So being able to vote with how, with some knowledge background. And that's going to be very helpful, having some science knowledge background to make some smart decisions. So either way you vote. But all right, that is it. So thank you so much. Bye.